I'm gonna move this over to my large screen so I can see it better. So I'm gonna be looking away from you all the whole time. All right, so great. So here's a very simple program, and it just prints out hello world. So first thing I want to ask you to do is just declare a variable. So as you remember, we've mostly talked about four main what we call primitive types: integer, double, Boolean, and string. So, and also when I've shown you declaring it, I've kind of taken a shortcut most of the time. I show you declaring it and initializing it at the same time. So tonight we're going to just split that up into two simpler things here. But so just pick a type. What was it? Integer, I think we call it double or float, or string or Boolean, and declare a variable. Okay. So it needs a, yep. Okay, great. Yep, perfect. Okay. All right. So this is both, like I said, this is both declaring the variable and setting it to an initial value, which is how I've always shown doing it because it's quicker and simpler. And usually when we're declaring things, we're initializing them. But to give more clarity, I want to split this into two things. So we want to just the integer age, that declares a variable. That's got the type, it's got the name. It just tells the compiler I've got a variable named age and it's an integer. And then we can put that on a second line where we set the initial value to 13. So declare another variable, or or change this one. So where we just declare it.
I want you to just declare it like that.
So when you declare it, you need to have the type and the name. Semicolon.
Oh no.
Great. Okay. And so so this declares a variable, and then from this point on, we never have to tell the computer that it's an integer ever again, right? It's like we declared it. We know the computer knows that it's an integer. Every time we say age, it says, "Oh, that's the box that has an integer inside of it." So now on another line, we can set it to some sort of value.
Like this?
Yep, perfect. Yep, great. So on line 4, we declare the variable. On line 5, we're setting it to a value. We're setting it to a value using the assignment operator. That's what we call the equal sign. It's an assignment operator. It takes whatever's on the right-hand side and puts it into the variable on the left-hand side. On the left-hand side, we can only have the name of a variable. You can't have anything else. You can't have numbers, right? You can't have expressions. You can't have the name of a method, right? The only thing we can put a value into is a variable. Okay. On the right-hand side, we can have all kinds of things. We can have, values like 13. We can have expressions like 13 times 28. We can have, we can add things. We can use functions if they return a value, right? So we can have all kinds of things on the right-hand side. But so let's try that. So might not make that much sense with age, but like use some sort of expression. So if you remember, there's a number of operators that we can use with integers, right? We can use add, subtract, multiply, divide. Just create some sort of expression using some of those operators.
And the variable, like here?
Yeah, for that, when you set age to a value. Yeah, on line 5, right? Okay. I like to put spaces around. I think it's clearer. The computer doesn't require it, but I think it's clearer. Yeah. Okay. And so now let's print out that value. Right. Okay. So if we run that, it'll print out still your age of 13. Cool. So we can put, so you created an expression that has other sort of constants, what we call constants in them. We could also use variables on the right-hand side, of course, right? So if we had like when we computed our area, right? We had two variables: a variable for height, variable for width, and then a variable area gets the height times width. So we can have, we can use. Why don't we do that? So create a couple of variables, set them some sort of value, and then assign those values to another variable. So do like the height, width, area thing.
I'm sorry, what did you want me to do?
Just declare a couple of other variables, like declare a variable for height and width, and set them to some values, and then compute the area. Mm-hmm.
Do you want me to print out the area?
Yeah, sure. Okay, yeah, and run that. Great. Okay. So these are variables, right? And variables give our program what we call state. So every combination of values for age, height, and width would be a certain state of our program, right? If age is 23 and height is 20 and width is 14 and area is 280, right? That's a state of our program. And if we were to change any of those values, so if we changed height to 21, that would create a new state of our program. So it's just the information that our program has. So another thing we can do is we can create methods, right? And methods provide what we call behavior. So like a variable is like a box with a value inside of it. A method is like a button that we can press. So like, do you have a refrigerator with one of those ice dispensers?
Yeah.
Great. So that when you press back against it, that lever that's inside, that's there in the refrigerator, that's like a button. It's like a right. You press it and something happens, and that's kind of like what our methods are. So let's create a very simple method. Let's just have a method that's like well, the other day when I did this with Pranav, it was raining. So we created a method called rain that just prints out it's raining. Or today we can say it's not raining. So what we have to do is we have to declare this method. And so the way we declare it is we say, just like that main method is declared, it's like public static void, and then the name of our method, and then curly braces. Okay, So the curly braces, yeah, you just stop there. Just hold on for a second. Okay, so curly braces are like a container. So like up on line 1, we see class main. Class main says, I'm creating a class and its name is main. And then there's an open curly brace. And then all the way down on line 14, there's a closed curly brace. Right? Everything between that open curly brace on line 1 and the closed curly brace on 14 is inside the class main. It's like, this is what class main is the stuff between the curly braces. Similarly, on line 2, we have all this gobbledygook, public static void main, string, args, right? All that stuff says, we're creating a method called main, and it has no return value, and it has this parameter. Okay, so it's just defining this method that we're creating. Then it's got, again, an open curly brace on line 2 and a closed curly brace on line 13. And everything within those curly braces, that's what is the method main. Okay, and so, and we don't want to put, and similarly, like with an if statement, right, or a while loop, right? We sort of have like if, blah, 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 open curly brace, closed curly brace. Everything that's within those curly braces is what happens if the condition is true, right? So curly braces are like a container for us. And we can't put, maybe, I don't know about the language, maybe you can or you can't, but for our purposes, we're never gonna put methods inside of other methods. So the method has to be sort of at the same level as the main. It's inside our class main, but it's not inside the method main. So that was a lot of speaking. Basically, that public static void rain method has to go after the curly brace that's on line 13 right now.
What method are we doing?
Let's call it rain. Right, has no parameters, no nothing. We're just gonna make like the simplest possible method, right? And just print out right there, just print out, you know, it's like it's not raining or just something. Right. Great, perfect. So this defines this method, and yeah. Okay. So this creates this method called rain. So now we've sort of created the button, right? We've created the lever on our ice dispenser, and so it's sitting there waiting for waiting to be pushed, right? It's like a mouse button, right? It doesn't do anything until you actually press down on it. So in order to use this button, in order to press the lever, in order to click the mouse button, we have to call it. We have to call this method. So now inside that main function, right? So within those curly braces, we need to call this method rain. The way we do that is we just say rain, which is we give it the name of the method, and then we use the parentheses. Great. Yep. Right. Now Pranav, one of the issues he doesn't. It's always this way. It's it's rain parentheses. The name of the method, and then the parentheses is kind of like what pushes the button. If we just said rain without the parentheses, it wouldn't call the function. Wouldn't do anything. It wouldn't compile. So it's rain and then the parentheses, and that's what's going to call. So now if we run this, it'll call our method. Great. So we call this method, and it's like I say, it's like the world's simplest method that we can have. Right? It's just doesn't take any parameters, doesn't return any value. It just does something when we call it. So when we press on it, it's like pressing the I don't know. It's like pressing a very simple button. All right. So there's a couple ways that we can make methods that are a little bit more interesting, right? This method, no matter when we call it, right, it's always going to do exactly the same thing. It's never going to change. It's always, there's no way to control what it's doing. It's just always, because there's no parameters, it's just always going to do exactly the same thing. But usually what we want is we usually want methods that do something a little bit different. You know, like um, a method that takes a floating point number and rounds it to an integer, right? It's not always going to return 3, right? It's going to, you know, it's, if we give it 5.5, then it'll return 5. If we give it 6.5, it'll return 6. So so we do that by defining a method that has a parameter. So let's define another method, and we'll have a method called say hello. Good. And so this is going to take a parameter. This one's going to take a parameter of a name. So it's going to, you know, say, hi, my name is, you know, Bob or whatever. So the way that we define our parameters is exactly the same way that we define our variables, right? Just like we have, you know, we give it, just like on line 4, we specify a type and then a name. Same thing that we're doing with our parameters. We give it a type and then a name. Yeah. Yeah, good. Right, and then just like print out, you know, hi, my name is name. Very good. Yeah, yeah, good. All right. And so now we call this method, we call it the same way that we called the rain method, right? We use the name and then the parentheses. The only difference is that in this case, within the parentheses, now we have to supply the value that we want name to be. Right. Right. We can call this a couple of times with a couple different names. Just like Bob or Fred is always good.
How many names am I making?
That's fine. Yeah. Okay, good. So the only thing that you said print instead of print line, so that's why it got jammed together. The print line is what gives you sort of a new, what they call a new line at the end of the string. Okay, so yeah, you can fix that up. Okay, good. So now we have a little bit more complicated button or method, say hello. Another thing though that makes them a little bit more complicated method is to be able to return a value. So we can create methods. These two methods, we just tell them to do something, and they sort of have the sort of side effect of printing something out to the console, but they're not returning anything to our program. Neither one of these could be used on the right-hand side of an assignment operator because they don't return a value. They're void, right? So, but we can have other things like if you remember the compute area function that we wrote a while back, it returns a value. It takes a couple values in, the height and the width, computes the area and returns it. And so that becomes a method that we can actually derive, use on the right-hand side of an expression. It's something that returns a value. So let's write one of those. So we can have well, I hate to repeat myself, but how about area of a triangle? That's just, you know what the formula for the area of a triangle is? I don't know if there's something. So it's just 1/2 the base times the height. So it's the same thing as the area of a rectangle, only divided by 2. So we're going to need 2 variables. Yeah. Yeah. Okay. Yeah. Okay, good. So the only thing is that, so area of a triangle returns a value. And so instead of being void, that void is the type that it returns. So we want this to return, since it's going to be 1/2 base times height, it could be a floating point value. So let's call it float, I think. No, those can be in it. Well, okay, go ahead. It doesn't matter. Right. Okay. But yeah, the function itself, right? That's it. The function itself needs to return a float.
So do I put in float?
Yep. Yes. Right. Good. And so how does it return a value? It has to use this keyword, which is return. So we would have to say like return, and then we give it an expression that's whatever it is that we want it to return. So in this case, we want it to return 1/2 height times base. So we would say return, oops. Right. Well, and then you got to divide it by 2. And actually, yeah, right. Yeah, that's fine. Yeah. Technically, I think you should probably divide by 2.0. Be best. Yeah. Okay. Right. So now we can invoke this.
By 2.0, not just by 2.
Well, so 2 is an integer and 2.0 is a float. And it's just, it's better form when you're dealing with floating point values to use floats. The compiler has to do less sort of converting from one type to another. All right. So now we have this method that we created called area of triangle. Now we want to use it, and we would use it similar to how we use the other two. And we can just start with that. We can just like call it. Right. Good. Okay, so yeah, what do you think will happen when you run it?
It will give us the area of the triangle, or give us the error.
Uh, uh, hmm. Well, you could just change everywhere it says float, you could just change it to double, would be one way to deal with that. Oh, okay. Yeah. So what happened when we called the area of rectangle, triangle?
I forgot to print it out.
Yeah, exactly, right. So how would we print it out? No, don't, no. Okay. So yeah, if you put a line of code there, like on line 29, the compiler would probably complain. So because you've already returned from the function. Returning from the function means you've stopped the function and you go back to whoever called you. So if you put code there, you can't put code there because you've already left the function. So we want to print it out from in the main method instead of in the area of triangle method. Mm-hmm. Okay. 15 times 17 divided by 2. I don't know. I'd have to check it on my calculator, but I'm sure that's correct. Good. Okay. So, all right. So any questions at this point?
Not really.
Okay, good. All right. So what we have is we have a bunch of state and variables, and we have a bunch of we call behavior in these methods that we've created. We call it behavior because when we call them, when we call a function, it does something. All right, so that's behavior. Classes are awesome because the classes combine state and behavior. It's one of the things that they do. They have state because classes have variables, and they also have method. You can't have a class that only has variables or only has methods, but most classes, in general, they have both variables and methods. So they provide state and behavior. So whereas a variable is just sort of a box with a value in it, and a method is a button that does something, a class you can think of more like a machine, right? So like on an ATM machine, right? An ATM machine has a bunch of buttons, right? And you give it a card, you give it your card, and you got a bunch of buttons. You can do different things. You can check your balance. You can get money. You can maybe even deposit money. I've never done that. So that's what, so a class is usually, sort of a more complex way of combining state and behavior, and it's a way of sort of modeling the real world, and it's sort of the next level up. But we're not going to actually create a class right now. I want to deal with Arraylist for a minute. So I want to declare an array list. So I don't know if you remember, but it's just array list. And so the type is array list and then some names. So let's call it like fruits. And so let's just declare it inside the main method, and let's do it at the start of it. So that's an array, not an array list. So let's stick with the array list for a minute. So array list is called array list. That's its type.
What? How do you do the array list again?
Just array list. ARRAYLIST. Capital L. And then call it, let's say we're going to have a list of fruits. So we can call it fruits. All right, and semicolon. And give it a couple blank lines. And then let's go up to line 1 in order to use array list. So most of the stuff that we've been dealing with has been sort of built into the language. Integers are built into the language. Floats and doubles, voids, all this stuff is built into the language. Strings are a class, but they're still built into the language. System.out.println is not quite built into the language, but it's sort of like well known, like the compiler knows all about system.out.println. You don't have to tell it anything. Arraylist is more of an extension to the language. So we have to actually tell the compiler, hey, here's where you're going to find Arraylist. So up on line 1, you have to insert a new line. And you have to say import java.util.star. UTIL, like utility, yeah. No, like it just UTIL, that's all. Yeah. Yeah, dot star. So it's asterisk, sorry. Yeah, semicolon. And then hit enter. Great. Okay. So we just have to give the system a little hint of where it can find information about ArrayList class. Okay. So we have this variable called ArrayList, and we're calling it fruits, and that's pretty common. So because list variables usually store more than one item, so we name them plurally like that, with fruits or lions or tigers or whatever. Another option would be, a lot of times I'll call something like fruit list or something like that, but something that indicates, the name should indicate, you wouldn't call it age, right? Because there's it could be 20 ages in here, right? Or fruit. Okay, the other thing though is that ArrayList, all the items in ArrayList have to be the same type, right? You can store anything you want in them, strings, integers, lions, whatever you want. But you can, whatever it is, it can only be one kind of a thing. You can't have ints and strings and doubles in the same array list. So we have to tell it what type of thing that we're putting in our list. And the way we do that is at the end of array list, we do this angle bracket, which is the shift comma and the shift period at the bottom of your keyboard. We have an open angle bracket, and then we give it the type, which is going to be string, and then a close angle bracket.
Sorry.
On line 6, you see where it says array list?
Yeah.
So we have to tell it array list of what? And the way that we do that is after the T, so back up one more caret. Oh. All right. Angle bracket, open angle bracket, shift comma. No. Delete. Backspace, yeah. Okay. The angle bracket is the character, it's shift comma. Looks kind of like a sideways V. like this. Yeah, there you go. And then type string, capital S, and then the close angle bracket, and then a space. Okay. So in this particular case, it's not sufficient just to say that the type is array list. You have to say that's an array list of strings. All right. Does that make sense?
Yeah.
Okay. All right. So now we need to initialize it. And this is just like we set the value of age, or we set the value of height or width or area, right? We need to initialize fruits to some value. And what it's going to be is it's going to be, because it's a class, we're going to initialize it using the new keyword. Yeah, you can do that. So space equals. And then we say new, and then the type, array list of string with parentheses. Okay, so it's not a new string. What's the type of fruits? What type of value is inside the fruits box?
With a string.
Array list of string, right? So, yep. Array list of string. Nope. Nope. What's the type of fruits? Yep. Yeah, and then with the angle brackets. Yeah. Yeah. Good. Okay. So now inside the fruit box is this new thing called an array list, and that's the value inside fruits. Okay. It's just weird because this thing that we're putting inside the fruits box can actually store a whole bunch of values. That's the only weird thing about it. Okay. All right. So array lists have 4 methods that we're interested in. Add allows us to add things to the list. Remove allows us to get things out of the list. Set allows us to change the value of one of the items in the list. And get allows us to get one of the items in the list. So right now, let's just think about add. So we want to add a couple of fruits to our list. So the way that we do that is we go down to line 7, yep. And like any time that we're dealing with an object, which is what fruits is, it's an object, it's an instance of a class. We have to give the name of the object, which is fruits. And then we say dot. So what that says is, it says we're going to do something with that instance of an array list of string. Right? We could have several, right? We could have an array list that's like, cars and fruits and friends and all kinds of things, right? So, but fruits is this particular one that we're working with. So we can say, and what we want to do is we want to add an item to it. So we say fruits.add. Right. Now, and then we use parentheses because this is a method. It's just like the methods that we wrote below, right? We're just using these parentheses, and we're gonna, now the add method takes one parameter. It's what is it that we're adding to the list? What value is it that you want me to add to this list? So give it a name of one of your favorite fruits, or the first fruit that comes to mind. Great. All right. And put a semicolon at the end. Okay. So what that does is it takes our list, it puts the value strawberries at the first location in the list. Let's add another one. Okay, great. And now we can print that out. Now, fruits is kind of smart. Or I should say Arraylist is kind of smart. We can just say system.out.println fruits, and it will print it out. It will tell us all the items in the list. Okay, so let's run that. Right, so you see up at the top there, printed out strawberries and pineapples. So you see it?
Mhm.
Okay, good. So strawberries, the way that we refer to the items in the list is not by their name, like strawberries or pineapples, because it can be anything, right? We could be, instead of strings, we could be putting integers or lines or something else in there. So there would be no standard way, right, of referring to the different items in the list. So the way that we refer to is with what's called the index of the items. And it just goes 0, 1, 2, 3, 4, 5, 6, 7, however many items there are on the list. So in this case, strawberries is item 0, and pineapples is item 1. So if on line 11 we said system.out.println, let's print out like the strawberries item. No, not on another line, on line 11. So just system.out.println, and then we'll worry about it. Okay, so yeah, so fruits, sure. Okay, so how are we gonna, so let's say, remember there's 4 methods, right? Add, remove, set, and get. Now in this case, what we want is we want to get the 0th item out of the list. We want to get, so we want to say fruits.get, and then using parentheses, we say 0, get the, parentheses, parentheses.
Sorry.
Yeah, great. Okay, and semicolon, and hit run. And so you see it printed out strawberries. So that's how we refer to individual items in the list. We refer to them using this index. And we do that for not for add. Add always, there's a way of using add to say, put it somewhere else. But when we just say add like we did, that just adds it to the end of the list. So it doesn't, we're not worrying about the index there, but with get, with set, with remove, we have to tell it, well, which item do we want to get or remove or change, right? And so we do that by using this index. And the index weirdly starts at 0. You may remember that Pranav asked the other day, says, well, how does it know like where inside the box is this value, right? And what it is it takes like, fruits kind of points to the start of the list, right? Well, if you add 0 to the start, you're still at the start, right? And then if you added 1 to the start, then you'd be down at the next one, and 2, and so on. And so that's why it starts at 0. There's some languages that start at 1, but not Java, not most languages. Most computer languages start at item 0 because of that. So you can think of it that way, that you're adding 0 to the start to get where you want to be. All right, so let's add a couple more items to, let's add a couple more items to the list.
Like here?
Anywhere. All right. And now let's change one of the items. So let's after line 12. So line 12 will print out what you've got there. And now let's after line 12, between lines 12 and 13, let's change one of which item would you like to change? Which one there is actually your least favorite?
Pineapple.
So just pick one of or I'll just tell you. Change so let's say that we want to change blueberries to apples. Okay?
Mm-hmm.
So what we do here, so we've used add and we've used get. Now this time we're going to use a method called set. And so what we can say is fruits.set, and then parentheses, and then set takes two parameters. It takes an index, and then it takes the new value that you want to put there. So blueberries is, what index is blueberries? Right. Mm-hmm. Right. And then just puts it, and then, right, right. And then the new value that you want to put there. Right. Great. Okay. And then just like copy and paste line 12 and yeah. Okay, great. And so you can see that worked, right? We took the third item in the list and changed it from blueberries to apples. And we can also use, there's another method called remove. Like if we wanted to just get rid of apples altogether, we could say fruits.remove parens 2, right? We only need one parameter, just like get, we only need one parameter that says which item we're removing. All right, so there's one other method called size, and that tells us how many items there are on the list. And so far we've been using system.out.println to print out the values in fruits, but suppose we wanted to not print it out, but like, do something else with it, like, let's say that we're integers and we wanted to multiply each integer by 3 or something like that, or we wanted to add them all up or something like that, right? And so what we need to do many times, very, very frequently in computer programs, I do it every day, we want to be able to loop through all the items in the list. We want to get each item in the list and do something with it. And so let's walk through how to do that. So the way that we do that is we declare a variable called I usually call it index. And index starts at 0 and goes to the end of the list. So we set up a while loop, and every time through the while loop, we increment index by 1. And so each time through the loop, the first time through the loop, index is 0, then it's 1, then it's 2, and so on. And then we stop when we're at the end of the list. So the way that we do that is we create a variable called index, which is an integer. So you can go ahead and do that. Right, and yes, then just initialize it to 0. Right, okay. And then just set up a while, just say while, parens, braces. And then we'll give the braces. Let's not worry about the condition right now. Okay. And then each time through the loop, the last thing that we're going to do in the loop is we're going to increment the index by 1. So we're going to say index gets index plus 1. Right. So if we just look at what we've got so far, we're setting index initially to 0, right? And then we sit in this while loop going around and around and around. And each time through, we execute this statement, and it says index gets index plus 1. So the first time through the loop, what's the value of index?
First time it'll be 1.
Well, before we do the add, what's the value of it?
0.
Right. So 0 plus 1 is 1, and we put that into index. So we take the value index out of the box, we add 1 to it, and put it back in the box, right? 0, 1, 2, 3, right? Every time through the loop, it's going up by 1. So we don't want that to happen forever, right? We want it to stop when we've reached the end of the list. So the way that we know when we're at the end of the list is we use the size method. So if inside a while, put inside those parentheses, put fruits.size parentheses. Okay, so fruits.size, the size method returns how many items are in the list. So in this case, what's it going to return?
Is it 3 or 4? Am I including the 0?
How many items are in the list?
4.
Right. It's right. It's a little bit weird, right? Because we start counting them at 0, but there are actually 4 items in the list, and that's what size returns. It returns how many items are in the list, just 4. So we want to go through when index is 0, 1, 2, and 3, not when it's 4, and certainly not when it's any bigger than 4. So we want to only do the while loop while index is what? To compare to size. So let's put while index, put index at the start of the parentheses. Right. Index space. All right. And so what should be the relation? So we want to do this while index is what? Greater than fruits.size, less than, equal to, what should it be?
Less than equal to.
Okay, try that. Okay. So, and then give a space. Great. Okay. So the right answer is just less than, not less than or equal. But you'll see that more when we actually like write out the rest of the code. Okay. So so before line 19, let's start another line. Before line 19. Okay. All right. So with what we've got so far, right? Index is 0 the first time through the loop. Then it's 1, then it's 2, then it's 3, and then 1, and then it becomes 4, and 4 is not less than fruits.size, and so it quits. So it does what's in the loop. It does the loop while index is 0, 1, 2, and 3. 0, 1, 2, 3. Anyway, so what we can do is each time through the loop, we can get that item from the list, right? The first time through the loop, we want to get strawberries, then pineapples, then apples, then cherries, right? So each time we want, that's the item that we want to deal with. So on line 19, let's declare a variable called string. I mean, not called string, but a variable of type string. That's like call it a fruit or just fruit. Right. So now notice that it's a singular word, right? We're using a singular name because we're just going to get that item out of fruits. So we can say fruits. How do we get an item out of fruits? Again, there's 5 methods really that we've dealt with. Add, set, remove, get, and size. So which one of those will give us one of the items out of the array list?
Get.
Yep, right, very good. Okay, so which item do we want to get out of the loop? I mean, out of the array?
Out of a number that indexes.
Right, exactly. Right. Right. So the first time through that loop, a fruit is going to be what?
Strawberries.
Right. And the next time through?
Pineapple.
Right. Exactly. And it just goes through the list. So then between lines 19 and 20, we can print out, we can say like, you know, the fruit is a fruit.
I'm sorry, what?
So we can print out the value of a fruit now. We can do whatever we want with this string, right? We've gotten our value. If it was a lion, we could, you know, get it, you know, we could get it to say whether it's hungry or not. We could, if it's an integer, we could multiply it. The string, let's just print it out. Good. Okay, you misspelled system, that's the only thing. Right, good. Okay, so that while loop going through a list like that is, like I say, it's very, 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 very common. It's like, and there's different ways of doing it. There's better ways of doing it, but this is, you know, an approach, a way of thinking about our list that is, you know, just used every day. Very, 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 very common, and something you should be familiar with too. All right, so we've talked about variables, we've talked about methods, we've dealt with an array, which is this crazy thing that lets us put more than one value inside our box. And we've dealt a little bit with a while loop that allows us to iterate through the items in the list. Do you have any questions?
Nope.
Okay. Was any of this helpful? Nope.
Yeah.
I think we only have like 1 week left and one session left, which is pretty disappointing. Let me see if I can. All right, well, I'll do that on my own time. You know, I was hoping that we could do a little bit of a fun project at the end. All right. Have you been to, let me just, all right, so let's just talk about one more thing before you go. So have you been to W3 schools?
Yep.
Have you gone through like Java exercises there or anything?
Yeah, I even been taking notes up on it.
Like, okay, awesome. Great. Has that been helpful at all?
Yeah.
Okay. All right. What, do, all right. Do you have any so you remember I talked about that Christmas list program, right? So if we did a program that was, let me look at you. All right. So if we did a program that was like a Christmas list program, right? Just, you know, we wanted to have some people, we wanted to have some gifts, we wanted to allow people to say, you know, what gifts they were interested in, and then maybe, you know, assign, okay, you're going to get this gift. I'm going to give it to you. Like, does that seem like something that you would be able to know how to get started on, or does that seem like something that's
I think I can start doing that.
All right. Maybe what we'll do Wednesday is we'll say like, okay, let's suppose that we wanted to do that, and then let's talk about how to analyze it, break it down, and how we could do it. And then you'd be able to maybe not complete it on Wednesday, but at least be able to get started on it. Let me ask another question too. When does your school start, or did it already start?
I think it's starting on like, for some reason it's starting on like on a Thursday. I think it's on the 20th or something.
Oh yeah, that sounds familiar. Yeah, I think you're right. Okay. So if we wanted to like extend this out for like another week or two, where we wrote some sort of program, that doesn't have to be the Christmas list program, it could be something that was more interesting to you. Is that something that you would want to do, or are you kind of like you've had enough? Or would you like, so let me give you three options. Quit and do something more fun. Work on some sort of program like what we've been doing, you know, these sort of like lists and, you know, lines and things, or drop it and start working on the robot. So we could like, I could show you like this robot that we have here, and we could write some simple code to like start moving it around. Which of those three do you think would be the most fun, even if it required like another week or two beyond what we were planning?
I think I want to start on the robot.
Really? Okay. All right. We can do that. I have to think about how to do that, but because it's weird. This robot over here, the way that it works is I take my laptop and I have to like network directly to the robot. Like I can't be on the internet with that laptop the way that it gets set up. So maybe you guys could like write a program and then I could copy paste it or something like that and onto the robot. And we could do that.
Okay.
All right, cool. All right. Well, thanks for your time, and say hi to your family for me.
Okay.
All right. Take care. I'll see you on Wednesday.